Well, happy Valentine's Day. Here is your video for Valentine's Day. I'll try to keep it short and sweet and to the point so that y'all can go do whatever you have planned for this evening. We're going to continue multiplying polynomials, but unlike what you did today in class, now we're going to be multiplying two binomials or a binomial and a trinomial. So all that has happened is we are still multiplying. We're just going to make the problems bigger. We're extending what we were already doing. We're going to do this by using a process called the double distributive property. Yesterday, all we did, or today in class, all we did was distributive property. You distributed one time, you did the distributive property and got your answer. Now we're going to do double distributive property because we're going to distribute twice. We will have two things that have to be distributed. Like this first example, the x plus 1 times x plus 2. We're going to have to do a double distributive property, so we're going to have to take this x and distribute it over here to this set of parentheses, and then we're going to have to take this 1 and distribute it to everything in here. So you see we're going to be distributing twice. I'm going to draw arrows so you can follow me with what I'm doing. So we're going to take this x and distribute it to this x. So x times x is x squared. And then x times 2 is 2x. So I've distributed once. Now the second time I'm going to distribute this 1. So 1 times x is 1x. And then 1 times 2 is 2. Now when you do this process, you are almost always going to end up with a pair of like terms or a couple pairs of like terms. They usually end up in the middle, but you should always put them together to make sure you are all the way simplified. So we're going to add these. So you end up with x squared. When I add these up, I get 3x plus 2. So my final answer is this trinomial right here, x squared plus 3x plus 2. That is the answer to this multiplication problem. Let's try another one. So we're going to do x minus 3 times x minus 5. So same process. We're going to do x times x, which is x squared. And then x times negative 5 is negative 5x. So you make sure you keep up with that minus sign. Negative 3 times x is negative 3x. And then negative 3 times negative 5 gives you a positive 15. So we write plus 15. Now you do have like terms in the middle again. So we're going to combine x squared, and then negative 5x minus 3x is negative 8x plus 15. There is your final answer. So you have gone from this down to this trinomial as your final answer. Okay, next problem. It's the same deal, except instead of just having an x, now I've got a 3x, but I'm going to do the same process that I was doing before. So 3x times x is 3x squared. And then 3x times 4 is 12x. Negative 2 times x is negative 2x. And negative 2 times 4 is negative 8. Put your like terms together, so you have 3x squared plus 10x minus 8. My pen does not like me still. I don't know what the deal is. Now this next one is a little bit different because it is not written like the first three were. It is not something times something. What I have is 2 minus y. All of that is squared. What it means when we square a number is that we multiply something times itself. So that means I am taking this 2 minus y and multiplying it times itself. So really it means I have 2 minus y times 2 minus y. So when I see this kind of problem, I'm going to rewrite it like this so I know I have to solve it like I did on the last one. So we're going to go ahead and multiply. 2 times 2 is 4. 2 times negative y is negative 2y. Negative y times 2 is negative 2y. And negative y times negative y is positive y squared. Like terms in the middle, so you end up with 4 minus 4y plus y squared. Or you can turn it around and put the y squared in front because that's traditionally how we see them. And you end up with y squared minus 4y plus 4. They're the same thing. It is not incorrect if you leave it this way, but this way you know these mean the same thing. It's just rewritten and turned around. So now that we sort of have the process down, let's extend it a little further. This next example is the same thing, except now I have double variables. I got x's and I have y's, and I'm going to have to take that into consideration when I multiply. So 2x times x is 2x squared. And then 2x times negative y is going to be negative 2xy. We traditionally put the variables in alphabetical order. 3y times x, we're still going to put the variables in alphabetical order, so it becomes 3xy. It's the same thing as 3yx, just like I said, traditionally we put the variables in alphabetical order. And then 3y times negative y is negative 3y squared. You still have like terms in the middle, so you have 2x squared. When you put those together, that becomes 1xy minus 3y squared. That's your trinomial. This doesn't have to be written. You have an x squared on the end and a y squared on the other end, and then you've got an xy in the middle. This is totally okay, but there is your answer as a 3, not a b. Maybe it will allow me to erase that little yuck. Should be 3y. There we go. Now the next example you will see, I have a binomial 3x minus 5 times a trinomial 2x squared plus 4x minus 3. I'm still going to do double distributive, but I'm going to have to distribute it to 3 different things. So I'm going to have lots of arrows going on here. So I have 3x times 2x squared. Well, that becomes 6x to the third, because 3 times 2 is 6, and then I add my little exponents. And then 3x times 4x becomes 12x squared. And then 3 times negative 3 becomes negative 9. So I have distributed once. So now let's do our negative 5. So I have negative 5 times 2x squared is negative 10x squared. And then negative 5 times 4x becomes negative 20x. And then negative 5 times negative 3 becomes positive 15. So now I have like terms. They just are not sitting right next to each other like they were before. The 6x to the third has no buddies, so he just drops down. Going to have to be a part of our problem, so we bring it down. But I have this 12x squared and this negative 10x squared. I'm going to have to put them together. So that becomes 2x squared. So I have plus 2x squared. And then this negative 20x doesn't have a buddy with an x to bring with it, so I'm just going to bring it down to negative 20x. And then I have these two little numbers. I've got negative 9 plus 15 that I have to put together. And so when I do negative 9 plus 15, I apologize, negative 9 plus 15 is going to be positive 6. And so instead of ending up with a trinomial like we did on the last one, we end up with a polynomial, because now I have 4 terms instead of 3. But this is my final answer. Nothing can be combined. I have an x to the third, x squared, an x, and no x. These are not like terms. I can't put them together. So now I have, there's my answer. So that's a binomial times a trinomial. So let's practice just a couple of word problems. So a square tabletop has side lengths of 4x minus 6 units. So I have a square. Kind of an ugly square, but it's still a square, and all of the sides are 4x minus 6. I want to find the area. Well, there's 2 ways to find the area of a square. You can either do area equals a side squared, or you can do area equals length times width. They're the same thing. They're just written a different way. But either way, I have to do 4x minus 6 times 4x minus 6. So I'm going to do this. 4x minus 6 times 4x minus 6. And I'm going to distribute just like before. So 4x times 4x is 16x squared. 4x times negative 6 is negative 24x. This is also negative 24x. And negative 6 times negative 6 is positive 36. So like terms in the middle, so you end up with 16x squared minus 48x plus 36. And so it's just more practice with multiplication. This is a shaded area problem, and this is a volume problem. We're going to go ahead and take care of the shaded area problem because it involves multiple steps, and this will be our last one. So you have a diagram that shows the dimensions of a sandbox and the wood frame that surrounds it. Write a polynomial that represents the area of the wooden frame or the shaded part. So I'm trying to find the area of the shaded region. So the first thing I have to do is the area of the whole thing. So I have to do 3x plus 5 times 3x minus 4 I'm going to do this without arrows this time. If it messes you up, I apologize. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. 5 times 3x is 15x. And 5 times negative 4 is negative 20. So like terms in the middle, this comes out to 9x squared plus 3x minus 20. So there is the whole thing. That's the whole big rectangle. Now I've got to do this little rectangle in the middle. This one's a little simpler because it's just a monomial times a binomial, so it's what we did today in class. So this comes out to be x squared plus x. But now I have to subtract this and this. So I have to do this minus this. So 9x squared minus 1x squared is 8x squared. And then 3x minus x is 2x. And then the 20 just gets to come along for the ride. And so there is your polynomial for the shaded region that has to go with that problem. So that is all there is to multiplying polynomials part 2. We will practice this tomorrow when you come to class. I'd like to give a shout out and a happy birthday to Gia. I hope that your day was fabulous, and I will see you all tomorrow.